Are you ready to explore exciting careers in neuroscience and neurotechnologies? Then join me, your podcast host, Dr. Milena Krastenskaya, or simply Dr. K, and my amazing guests on the Neurocareers Doing the Impossible podcast. Discover what it takes to turn the impossible into reality. Tune in now to a thrilling episode number 45. Dear Neurocareers podcast listeners, welcome to yet another adventure into an amazing world of careers in neuroscience and neurotechnologies. With great pleasure, I would like to introduce to you our today's podcast guest, Dr. Nikolay Novitskiy, from the Department of Linguistics and Modern Languages at the Chinese University of Hong Kong. I know Nikolay from my PhD studies at the Cognitive Brain Research Unit at the University of Helsinki, Finland, and I'm very curious to learn about his unique academic journey that brought Nikolay from doing brain research in Helsinki, Finland, to Hong Kong. I'm familiar with many researchers in the field of brain research, but Nikolay is the first to make it that far. Welcome, Nikolay. Thank you so much for joining us today. I'm recording this podcast at 9 a.m. Eastern Standard Time. What time is it in Hong Kong now?
Hello, Milena. Thank you for inviting me to this spectacular audio show. It's quite late in Hong Kong. It's 10 p.m. I'm quite excited and looking forward to your questions, and hopefully we will together find out something interesting about neurocareers and the neurocareer diversity.
Yes, exactly. I think this should be the main topic of our conversation today. Thank you so much, Nikolay. And by the way, what does the weather look like during the beginning of February now in your place?
Well, as the local weather forecast tells, it's very cold, which means plus 17. It cannot be colder here ever. Yeah, I haven't seen snow in a couple of years, actually, in 3 years. The trees are green, and so it's a tropical climate. It's different from what you would experience in Europe, especially in Helsinki. So that's a big contrast with the and cold Finnish winter.
Yes, yeah, it is a contrast. Can you briefly introduce yourself and share any interesting facts or information about the place you live in?
Well, you already introduced me in big detail, I would say. So I have been doing my PhD in Helsinki. Then I lived in some other places as well. Interestingly, that I changed the departments from the biology, which is my background as an undergrad. I switched to psychology in Helsinki, and then eventually I ended up in linguistics. But that's, I would say, a superficial difference, because in fact, all the time I'm mostly doing the EEG research, and due to the diversity of this method, and you can apply it to various fields, including linguistics, and I think application in linguistics is one of the most promising at the moment.
Yes, I absolutely agree with that. And we will talk about this in more detail, actually, in many different details, I hope. Can you tell us a little bit about the place you work at the moment, the Chinese University of Hong Kong, and what are the unique features and strengths of this institution?
There are many universities in Hong Kong. So Hong Kong is part of China, and it's a big educational center within China, but also you can say in the whole world. There are 6 major universities in Hong Kong, and if you follow the world rankings, most of them usually end up in the top 100 of the world rankings. So Chinese university is not an exception. So the institution, which has been founded not so long ago, so it's we're speaking about the 1960s, and its uniqueness is in the attempt to combine the most interesting tendencies from the Western science and the Chinese tradition. That was the original goal. In terms of linguistics, it means that we have a unique opportunity to study the specific features of the Chinese language, such as tones, the lexical tones. You probably know that the Chinese language uses the frequency of the tone, the frequency of the voice, the pitch of the voice as the distinctive feature for the phoneme recognition. And that places speech, the research of the language in connection to the study of the frequency recognition. That was my topic of my PhD. Our current project is the construction of a predictive model based on the EEG response to the Chinese lexical tones that would predict the development of speech in children during their first years of life and hopefully in a later period.
Yeah, that is a very interesting project. And I would like to ask you to tell a little bit more, especially to those people who are not familiar with event related potentials, evoked responses. What is the method that you are using? Maybe you can describe it in simple terms.
I will try to. First, maybe we should mention that the ERP is just a special case of the electroencephalography, which is probably familiar to most of the people, even as a clinical tool, a diagnostic tool for epileptic seizures. So when I started my PhD about 20 years ago, EEG was already an established method. We will be probably celebrating 100 years of EEG alpha wave discoveries in the maybe even next year. It's an old method, and when I was starting my PhD, there were already a rumor that it's actually time to discard it because there are new methods of brain imaging looming in the horizon. Like that was the time when the fMRI starts its ascent to the place which it occupies now in the brain research. So that everybody likes the brain maps with the colorful spots, and even the people in advertisement, they pick it up, and sometimes you can see the illustration of the activation in the brain as a confirmation that you can or you cannot perceive something during the, for example, a product choice. But funeral of EEG was a little bit preliminary. It was not something which happened. And the main reason for that is the high flexibility of the method. Actually, in our times, when I was an undergraduate student, the EEG recording required still a huge device, and we're just switching from the paper recording to the digital recording of EEG. Modern day EEG device with the same power can be placed in a palm of the hand, and it can work wirelessly. And there are some models which can work without any additional connection, like the dry electrodes connecting to the skull. Due to development of multimedia devices, you can also present a variety of stimuli to the subject during the EEG recording. And then I would say the third major achievement is, of course, the analysis and the methods of EEG analysis, which are developing quite fast. And the information from EEG can be extracted in much more detail now by using the methods such as machine learning, for example. Well, back to your question, actually, it was just a preliminary review of EEG. ERP, the event-related potentials, is a subfield of EEG which focus on the brain responses, mostly phase locked to some kind of events in the environment. In our case, that would be the speech sounds. So when I record EEG and present, for example, auditory pitch sounds like syllables, we can then record the brain response to the different features of the speech sounds, including the pitch, which is currently my main interest, the pitch of the voice. And ERPs generated in different levels of the central nervous system, starting from the brainstem to the cortex. And here I should stress that my current topic is mostly related to the brainstem responses. So we are coding the EEG components called frequency following response. That is a neural reflection of the fine structure of the auditory sound.
That's very, very interesting. I would like to hear more about that because I know that you were starting your career, your work with the fairly late responses. Yes, probably around 100 to 100 milliseconds.
Yeah, that's correct.
And now you went to basis to the brainstem, which just, I think couple of milliseconds, even less. So it's really, really.
Yeah, it's then set within the 10 milliseconds. Although the response itself lasts as long as the sound lasts, because that's beauty of this response, because you can get a reflection of your stimulus in the brain. So you present something, and then the brain gives you back the picture how it sees this sound, and that happens mostly on the brainstem level. Long latency potentials, they are very important also in the research of different areas, including speech. The problem of the long latency responses, which is also its advantage, it depends on how you look at it, is that they are very much dependent on their current context. So, as you know, of course, with mismention negativity and with P300, so you can change the amplitude latency of response by changing the order of the sounds, by changing the probability of the sound, which is great when you tap into the fine psychological reactions to the sounds. But when you want to develop a diagnostic tool, often it's mentioned like a problem of the long latency responses, cortical responses, that they are not so well reproducible from one session to another, and it depends on the different environmental factors. I know you use mismatch negativity for schizophrenia research, and you may object to that. The long latency response can be also used as a diagnostic tool. My point is just that with simpler and more reliable response, they may be more straightforward to go to the clinical goal.
Yeah, that's very interesting approach. I'm so glad to see how these initial brain responses are now being utilized in a very different settings and roles, not just for clinical diagnosis, which brainstem potentials often were used, but actually for language and speech sound research, which is, I think, fascinating. Can you tell more about possibilities to apply this type of research in clinical settings? Because this is what you were talking about. The main rationale of using brainstem responses is eventually to use this for diagnosis. So how this diagnostic application would look like if it actually would really happen?
Principle is that we extract different features from the brainstem response related to the accuracy of the mirroring of the sound, and then use machine learning to predict whether the child will be top or bottom in the distribution of the peers in relation to the speech development, which is measured as the standard number of produced words, the number of understood words, and similar measures. It's a part of a great research project, which includes not only EEG, but a lot of behavioral methods and the parents' questionnaires and so forth. So I'm responsible for part of it. And I would say that we get some good prediction, which is recently has been published in the clinical related journal. Yeah, that's a process which is going on.
Yeah, thank you so much, Nikolay. This is a fascinating project. I saw that you and with your team very proliferous in publishing. There are so many publications on this topic, and the development of research project is advancing. It's evident from all your publications. Maybe you can tell the main findings so far that you are proud of in this area that you are responsible for about this predicting speech development.
Yeah, well, that's just to repeat that the accuracy of prediction says for itself. So we have about 80% accuracy for the placing the child into the lower quartile or the upper three quartiles in the distribution of the peers related in relation to the in connection to the speech outcomes at the age of 1-2 years. And important thing with, I don't know if I mentioned it already, we use the EEG in the recorded in the first year of life when infant is not able to speak by definition, because the meaning of the Latin word infant means infant, the one who cannot speak. That's the definition of the infant. So that's the first year olds, they just start learning to speak. And if you are capable to record the EEG and predict the speech outcome later in 1 or 2 years based on the recordings during the first year of life, that means you gain some time in the opportunity to start speech therapy and to help those kids which are predicted to be, I wouldn't say patients, but they would be like a bit lagging behind the rest of the group. So this is based on a big body of research saying that actually without intervention, the speech development is quite stable in infants and later in children. There was a study on a big sample demonstrating this stability up to the teenage period, after the up to maybe 15 years old. So that means that you would predict that predisposition already present at birth or during the first 1-2 years. It's very important for later life, and what we see in this period can tell us what will happen later in life, but also what we do in this period can help children later in life. Of course, it's related to the problem of the genetic predisposition in language acquisition, and that's another topic which other people in our group are working on. So the analysis of the multiple loci in the genome of the infants, and trying to connect them with this further speech development with the speech acquisition. Yeah, I would say also that the whole idea that speech may be determined by biological factors is sometimes controversial, and it was more controversial 20 years ago when I was doing my PhD. I would say that was the time when the predominant opinion was that infant is a tabula rasa, the blank slate. But ever since, a lot of research has demonstrated that actually we have to look into biology to understand the development of most complex speech features.
Yes, absolutely. Thank you so much, Nikolay. That is a very interesting topic, and I hope we will dive in even more into it. You are working with the predictive models, you are using machine learning approaches. And my question is how this explosion of machine learning approaches, which happened fairly recently, that it really exploded, how did it influence the work you are doing?
Currently, we are building multi-factor models, and we're using this algorithm which learns from the data. I would say I'm not really the person to be asking the details of the algorithm. As you know, most of us, biologists, psychologists, linguists, we're using the algorithm which given. So in this sense, there is a lot of discussion of whether this machine learning research gets too much attention, or so I heard this joking reference that what was called statistics in all the times now it's called machine learning. Yeah, and then when the people are making models, then they say that the best model of a cat is a cat. So that's like whenever you do a model, you do simplification and you get a less accurate representation of what actually happens in nature. But another saying says that nature is complicated but not ill-intended. So the nature doesn't have tried to deceive you. So it's just that with a sufficient motivation and effort, you can get into the complexity which offered by nature. And it's probably never too much to stress that brain is the most complex things of all the things which exist in nature.
Thank you so much for this update. And what are your future plans, next steps in developing this project?
Actually, I can already say it. We are at the final stage of filing the patent in the Chinese patent organization. I'm still not well familiar how it works, so it's the very first patent which I took part in it. And of course, I'm not the main investigator. I'm afraid to say inventor, but this is an official term. That's when you apply for a patent, you automatically become an inventor. My supervisor, Professor Patrick Wong, he is planning to develop this currently research tool as eventually as a clinical tool for helping including the children with the abnormalities like autistic children.
Maybe dyslexia possible as well?
We are currently not so much focused on dyslexia, so there is a project related to the cochlear implanted children. Importance of the preterm infant studies arises because more and more infants, babies, are born preterm. This is, again, actually a good sign that it means that medicine is advancing to the stage when infants which would not survive the birth before they actually get born, but many of them get born preterm, and by being born preterm, they carry the risks of different kind of diseases, including the speech disorders. So that's about 11% of the preterm infants known to have a risk for speech disorders.
Thank you very much. That's very interesting information, and definitely there is a huge potential of the work you and your team are doing to create a significant clinical impact. So I wish you all the best with continuing this project and making this tool available, which would be amazing. You also mentioned at the beginning of our talk that the linguistics is one of the primary area that is being investigated with electrophysiological methods such as ERPs, EEG. Why this area is so important, and there are so many resources allocated to it and so many laboratories that are working on this type of investigations.
I think it's self-evident that language is important in our life because it can be illustrated by the problems when you not hopefully not you, but a person would experience if due to some unfortunate circumstances, for example, aphasia, and you lose your ability to produce speech or understand speech or both. And this person would superficially look almost like healthy. The motor functions are untouched. One of the research group even has even shown that those aphasic patients, they can play chess, for example, but the life quality is very much reduced, and that's why then when the neurosurgeons are surgery on the tumors in the brain, we have a double task. So first task is to remove the tumor, of course, because that's what makes the life of the patient in danger. But the other task is to keep intact the areas of the brain which is related to the vital functions. And among vital functions are, of course, motor functions, movement of your limbs, which is obvious, but also speech. So that's also one of the recent application of fMRI. Here I return to fMRI, when you can use mapping speech-related functional area in the brain with fMRI and provide this information to the surgeons, and they would map it together with the tumor and plan their surgery so that save the most of these important speech areas.
Yes, absolutely. And I was thinking about this approach when you were talking about extracting features from the sounds that you are gathering in your project. So you have all the stages of brain computer interface except for the last one when you already translate the features into the commands, yes, to the person or to the device. And that was my question, that maybe you have some plans already of including that last stage.
Yes, we have this plan to introduce as a brain-computer interface. Here we run into this problem that compared to the long latency response like P300, and that's the most common brain-computer interface feature. In our case, the brainstem response, they are low amplitude and they are low signal-to-noise ratio. So in order to record a reliable response, we need to repeat the stimulus about 1,000 times. And this is not the optimal configuration for brain-computer interface, because in the ideal case, you should make it flexible and change with a matter of several trials. In our case, you have to wait. We are also trying to reduce the number of trials. That's an important task. So actually, if like the classical papers would say that you need 2,000 responses, would say that right now we can record reliable response with 600 repetitions. Yeah, that's So in future, yes, that's the interesting prospect. So if you can also tell a robot by listening to the sounds whether you need to do this and this, it's possible also to use it in language learning. Of course, that's why it's so interesting to study the Chinese lexical tones, because for non-tonal languages, they are always a mystery. So the sounds which I use now, I have been using them for 5 years, and they're two ga syllables with the free tones, and I can distinguish them because I know that there are only 3 of them. But if you would ask me in a blind test to categorize them, I would still probably fail. So that's difficult for non-tonal language speakers to learn the tonal language. I would say, of course, that works both ways. So every language has some unique features. And by learning foreign languages, of course, I learn a lot about my native language, I would say our native language, right? Russian language, which, for example, is rich in consonant clusters in the syllables. And that's part, it comes so natural if you're a native speaker, but then you try to explain it to speakers of the other languages, they tend to swallow the part of the consonant cluster because it seems unnatural. Yeah, that's what you have several sounds in the beginning of a word. In order to better understand how the native or non-native speakers perceive those tiny differences in the acoustic structure of the sounds, brainstem event-related potentials are the best available tool. I'm coming always back to that comparison between ERPs and fMRI. And of course, the main advantage of EEG and ERP is the time resolution. So even though the fMRI and other brain imaging techniques, they are making progress and there's better time resolution than in the older times, but still EEG is the only method which actually follows the neuronal activation in real time in this. It works on the time scale of the neurons themselves. So that's the big advantage. So we are working with millisecond and microsecond time resolution. In case of the brainstem response, we going into the microsecond area. So we record the responses with a sampling rate up to 2,000 hertz to 20,000 hertz to 20,000 times per second. So 20 times per millisecond. So when they say, I often give this example that when we say something is fastest, that happens, we say, in a blink of the eye, right? Well, duration of blink of the eye is 200 milliseconds. That's not the minimum when we can reach. So we go to much shorter time scale than the blink of the eye.
Yes, I so much like this comparison. It brings me to the area of neuromyths. So this is something that I became familiar recently in more detail, that there are so many things that we're saying about how the brain works, the things that we are absolutely convinced, but it's not a reality. Yes, like blink of an eye, actually everything happens much faster. Yes, in say our brain and in the processes. Maybe you can talk about some neuromyths that are specifically related to language acquisition, speech, area of neurolinguistics, anything that is related to this field. You know, one of the examples, just to give an example of the brain myth, that we're using only 10% of our brain, yes, which still so many people believe, yes. So maybe you can give a couple of neuromyths if you can think of in your area of research.
If you allow me, I would defend some of the established concept which has been questioned by the non-neuro research, which find more and more justification in the neuro research. So and then one of those questions is the critical period in the language acquisition, where the development of postmodern approaches become fashionable to say that everyone can learn language anytime. You just need motivation and the proper environment, maybe. Neuro research shows that there is such a thing as a critical period in the acquisition of, for example, as we both know, the native sounds of a language. So that's the classical work of the mismatch negativity when, yes, so that before the 6 months, the response to both native and non-native sounds look similar. But after 6 months, 6 months and 1 year, there's a dramatic change in the response to native and non-native phonemes. So that indeed, after when the child is already acquiring his mother tongue, the child can already make difference between the native and non-native phonemes, and that stays, basically for the whole life. Even the studies on the adoptees, which were moved to a different linguistic environment in very early age, in the brain response, they still preserve the reaction to the original mother tongue. So it's more similar to different from the children who grew up from birth, from womb, into this environment of new home language. Here, I would say that neuro research, I think, will also contribute to the concept of the mother tongue. Not only that it confirms that you learn it during the first years of life, but also it has been shown that in the latest stages of the womb development, when the fetus is in the mother's womb, she can still hear the sound of the environment, and it matters which kind of sound she hears. So, and whether, including which kind of language is in the environment. But of course, then there is a case of bilinguals. Of course, it's another big area where what happens in the infants when she is exposed to two languages from the cradle, or when the child in the later stages gets into the environment of another language. So bilinguals is actually also another field of brain of neurolinguistic research to which I contributed a little bit. So we had in my previous work in Russia, in Moscow, we recorded ERPs to the Russian English bilinguals. We look at responses to the cross-linguistic homophones, the sound which are similar between languages. So that's without context, it's difficult to say to which language they belong. We find that the reaction to them is as if they are stored in the same lexicon. It's a very promising, I think, area of research, partly because it's in its infancy, just to use the pun. It's in its infancy in the way that it cannot speak for itself as yet. You have to push it and to interpret what kind of outcome is produced within the neurolinguistics. But it will grow up and it will mature, and eventually we will see that this is it will show a lot of interesting insights about the.
Yes, absolutely. It's an amazing area, and I loved your comparison with the infant. My question is, how do you foresee this area becoming an adult? So, how do you see the field of neurolinguistic research, let's say 20, 40, 100 years from now? You can pick the date.
There are people who say that in 2045 we'll have singularity and everything will change. Those people usually connect the progress with the further development of machines as our helpers, but eventually as our partners, and finally the substitutes of our bodies, right, and even the brains. My view of the future is more, I would say, grounded or more biologically determined. And I think language acquisition, first language acquisition, the mother tongue acquisition, and the learning of a foreign language in the older age and becoming bilingual is a very challenging area, but it will, and that's where I would expect to have progress in. So we will eventually, maybe with the help of a brain-computer interface, we get the ability to acquire languages without those limitations which exist due to the biological structure of to the biological determinants of language. So if we understand what defines critical period, if we understand what defines their native, non-native phonetics and even syntaxes eventually, then we can cross this border and enable anyone at any age to acquire a different language. The existence of the different languages and the development of the mother tongue should not be underestimated, but it should be better understood. And then if we understand and if we use this knowledge into new techniques and new methods, then the barriers between different languages could be overcome.
Yeah, I think that's a very interesting point that you are making. Thank you so much. We talked a lot today about language. You mentioned learning different languages. And my question is, what do you think is the value of knowing multiple languages in the career development in the field of research?
If we just superficially look at the academic landscape, because English is the dominant force here, and you can survive this landscape with English alone, of course, it gives an advantage to the native speakers of English. But I would say that this is, again, superficial view, and if we look a little bit back into history, that's the dominance of English. It's a very recent thing. It has maybe less than 100 years behind it. So before, other languages like German and French were quite prominent, and of course in the East Asia, Chinese language was a written Chinese language was a lingua franca for millennia. So that's and when we say Japanese language also, but the writing of Japanese and Korean and Vietnamese languages were for a long time were based on the Chinese characters, so that was kind of understandable between each other. So, and then if we come back to Europe, there was Latin before that. So the conclusion for the future, I think you should be sensitive to the new trends and not invest all of your effort in one language, because that's, we don't know how much it will last. That's one thing. So that's just very practical thing, that it's good to have one spare language. So it's not just to be monolingual. Besides all other advantages which can then bilinguals can bring to you, but you have some kind of an additional area. Then when you learn languages, you of course, you see the connections, you see the origins of the different words in different places, sometimes unexpected. So the story which I liked recently is the story of the word for tea. I don't know if you know this, like this in this sense, of course, Lithuanian language is very unique because it has its own word for tea, right? It's arbata, which is it's not used in any other language, but most of other languages except the Lithuanian have the word for tea originated from two words. It's either similar like tea, te, or like Russian chai, Indian chai, and like Portuguese also chai. And both pronunciation of the word for tea, they of course come from Chinese, because that's where the tea or chai was grown. And I should say the standard Chinese nowadays and Cantonese, they use the word chai and Tsai. And the origin of tea is much more obscure. It's actually it comes from one of the dialects of the east coast of China, from Hong Kong, that would be northeast. It's just that different merchants from different countries, they bought tea either from Guangzhou, the Hong Kong area, future Hong Kong area, or from this eastern province in Fujian. And I would say that actually officially it was allowed to sell tea only from Guangzhou. So that was the only open trade port for the foreigners for a long time. And that's where the Portuguese brought it, and Russian and Indians, they bought it by land route. So why the Dutch and later English people, they use the Zen dialect. Apparently, they were smuggling tea. So they were not buying it from Guangzhou, where it was open port. They were just coming in the darkness of the night, and they were smuggling it from the East Coast, and that's why they learned this word from the people. Like not even average Chinese person from other area would say that this word from the Fuzhen dialect. So but it becomes a global word because this entrepreneurial people. So I give this illustration just to say that you learn language, you learn some of the things which are hidden in this language, and that we are not so obvious until you realize the foreign origins and the history behind them.
Yeah, thank you so much for this interesting story. And what was the main challenge in your career development, especially when you already moved to Hong Kong, and how did you overcome it?
Yeah, my biggest challenge since I made my PhD was, of course, to obtain a permanent position in the academia. Sorry to say, I didn't overcome it. I'm still holding temporary positions. So that's my current position as research associate, which is a kind of postdoctoral level position. As I didn't overcome it in practice, so I didn't become a professor. And mentioned that in among to a new colleague, I say, I think I will never become a professor before 40. And she was saying like, oh, but no, you should be like optimistic. Why you're so impressive? So there's one reason why I'm already 45. So I will not become a professor before 40. After you become 40, actually, you start looking more like lightly on those matters. Life doesn't stop at 40. Actually, life only starts at 40. So that's a complete. After 40, maybe you stop perceiving the life as a continuous race, and you stop thinking of different marks of achievement, because that's what actually that rules the life, especially between 30 and 40. That's when you try to look around, see who is running where, and in this sense, I did overcome this challenge because I start caring less. So that's how I overcame this. Yes.
Very good, very good. Yes, so you did overcome it. Wonderful. Um, Maybe you can think of some example when you thought that something is absolutely impossible and you made it possible in your life, in your career.
Yeah, maybe that was this episode in my career, which we didn't mention yet. But this is when I worked for a company, when I moved to industry for a short time. That looked absolutely impossible because I considered myself, and I still consider myself more like academic person. So before and after. So one thing is to be academic person in your mind and in your approach. The other is to try something which is different from the university, from the academy. It's not impossible after getting a PhD and even after some postdoc years to switch to a company, especially if it's a company which anyway works with academic customers. So you see, you can already start using the parlance of the business world. So in this world, we are researchers and partners and collaborators. In that world, there are customers and the manufacturers and dealers and suppliers. Yeah, it is a different mentality, but it is possible. So
Yes, that's a very interesting experience, and probably it took some just flexibility in your thinking, in thinking about the things, how they're done, and overcoming those boundaries that we are imposing on different fields within this big arena of neuro research, neuro industries, and so on and so forth. What would be your advice for making seemingly impossible possible?
So the only thing which is impossible is the one which is mathematically impossible. Like you cannot become a professor before 40 if you're already 45 and you haven't become a professor. So that's impossible.
Thank you so much, Nikolay. What about those people who are very interested in exploring a career that is similar to what you are doing in this field and in China or Hong Kong? What would be your recommendations? Where can they start looking for such positions? And also, what would be the most valuable skills for them to really be accepted and wanted at the places in linguistics, neurolinguistics research in Hong Kong, China?
In your position, they think the best strategy is to visit conferences. It's fashionable to call it networking, but with all digital developments, seeing a real person is a big difference. Yes, many people underestimate their own values as future postdocs. This stage is always in demand, so there's always new labs opened, and then, like, of course, there are PhD students required, but always also postdocs required. Don't underestimate your potential after defending the thesis.
Yeah, I absolutely agree. I would support that advice 100%. With getting your PhD, and so many doors opening after that for you. Thank you so much, Nikolay. I wish you all possible success in your work, in your career, and just living the beautiful and, in my opinion, very unique life that you are living. So, thank you.